Hi everyone, so this is 4.3 on page 288. Okay, so it is another math lab, so it's going to be quick. So let's get started. We are going to be looking at the graph of y equals x squared. This one, y equals x squared, is the parent function of the quadratic equation or quadratic function because everything starts with this. Y equals x squared is a quadratic function, therefore it is going to be a parabola. So let's look at how we begin with this lesson. So here is a graph of two parallel lines. Okay, one, y equals x plus 1, 2, y equals x minus 2, which translation would move one line so that it coincides with the other line. So to translate a graph means to move it left or right or up or down. All right, this was done in probably around grade 7 or 8. Okay, so if you look at this one here, all right, you could translate it, all right, by moving it. If we go up or down for now, all right. So if we move this up, it would not hit this line. So we have to move it down, all right. So how many units do we need to move this down to get to coincide with the other one? Well, if we choose one point here, this point, we need to move it down so that it will hit this point. How many units? 1, 2, 3. All right. So that means, so translate the y equals x plus 1 line 3 units down. All right. Now, if you do it this way we're in, you will be moving this up instead. You will translate the y equals x minus 2, 3 units up. Still the same, right? Or if we go left or right, we could also say now if we move this to the right so that it will coincide with this one. If we look at this point, which should move over here, how would that be? We move it 1, 2, 3. All right. 3 units to the right. Okay. So you can also do this. Translate the y equals x plus 1 line 3 units right or to the right. Okay. Now, how can you change the equation of one line so that its graph coincides with the other line? Now, some of you might not, excuse me, might not be sure of how to do this. So let's take a look at the Desmos, okay? Okay. Stop sharing. All right. And then I will look at this one. All right. So guys, look, I hope you see this. Okay. So the red one is y equals x plus 1. The blue one is equal to y equals x plus x minus 2. Now you will notice here that I have y equals x, the third equation, but it has no graph. So I will click this. So now you see a green graph, all right? Now guys, I want you to take a look at what I'm gonna do, all right? So y equals x. Let me play around with this, all right? So what if I add 0, okay? Obviously nothing happens, okay? Now guys, take a look, all right? So what if I add 1? Where did the green line go? All right, did you notice? So I'll remove it, okay? So when it was y equals x, it was a diagonal cutting through the the quadrants 1 and 3, all right? Now, when I added 1, Where did it go? Okay, if you didn't notice, I'll do something else. Instead of x plus 1, I would put x plus 2. Oh, there's your green. What about x plus 3? X plus 4. Do you notice now? When you are adding something to y equals x, all right, it is moving to the left. Okay, all right. Now, you could also think of it this way. As it is moving to the left, isn't it moving up also? Okay, look, I'll do it again, all right? So y equals x plus 1. Oop. Y equals x plus 2. All right. Y equals x plus 3. Oops. There it is. All right. So for now, I want you to focus on what is happening up and down. All right. So for this one, let us just look at it as, oh, it went up 3 units. Okay. But of course, it also went to the left 3 units. So having said that, if we are to compare the original, the green one, y equals x, the parent function, and we want to coincide with the blue one, I think since we already know that if we are to add something to x, it moves up. Therefore, we need to subtract something from x to move down. So if we subtract 1, it should go down 1 unit. Let's take a look. There you go. All right. Therefore, if we subtract 2, then it will coincide with the blue one. Let's take a look. Oops. There you go. All right. As you can see, the blue is gone. The green is there. So I hope you saw the connection there when you are adding something. If we are looking up or down, when you're adding something to x, it went up. If we are subtracting something from x, it goes down. Now we will take a look at what it is about going left and right in a little bit. All right. Okay. Let's continue. Oops. Stop share. All right. So okay, here we go. So translate the y equals x plus 1 line, 3 units to the right. That is what we saw. How can you change the equation of one line so that the graph coincides with the other line? So we already saw what happened in the Desmos activity. All right. So you can subtract 3 from the you can add 3 like here. So y equals x plus 1. What did we do? All right. We moved down 3 units. So really, we can subtract 3. That's moving down 3 units, which gives us y equals x minus 2. That's why it now coincides with the other one. All right. While y equals x minus 2. All right. You had to move it up by 3 so that it coincides with the first one. Does that make sense? Hopefully it does. Thank you. All right. Moving on. So, okay. So, so the next one says, use graphing technology. Start with the equation of the quadratic function y equals x squared plus q. That's construct understanding A, and then choose different values for q. Use 0, positive and negative values. Graph it and look at what is happening to the graph. So I already did it myself, guys. So I'm starting with this equation, y equals x squared plus q. So the q will be any number, and the suggestion was try a 0 and then try a positive, try a negative. All right, and you should see something that's happening, and then graph it. So in my case, what I chose for my first q was 4. Therefore, y equals x squared plus 4 is my function. Okay, so this one should have been 4. All right. Okay. All right, so That's 0, 4. Okay. Now, 0, 4 is the y-intercept. The second one, oh, by the way, what do you notice? There is no x-intercept, right? Okay. The second one, when q is equal to 0, so it's actually y equals x squared plus 0, but you don't really need plus 0. So this is the graph. What do you notice? It has its vertex here, and it has one x-intercept. What about when q is equal to -1, so it becomes y equals x squared minus 1? Okay. It has two x-intercepts, and the vertex is right here. All right? Okay. Now, a quick summary of this is when your function or your function would have a positive coefficient for your x squared, meaning it is going to be opening up, and then something is added to it. So positive coefficient opens up, then something is added to it. That means it would be above the x-axis. That means it would not have an x-intercept. If it's y equals x squared, it will only have one x-intercept. The vertex is right on the origin. When you have a positive coefficient for x squared, and then you subtract something from it, means it moves down. You will have two x-intercepts because the vertex is going to be below the x-axis, and then it opens up. Okay. Next, y equals x minus p squared. Choose different values for p. Use 0 and positive and negative values. Graph the function for each value of p. How does the graph of x? Okay, same thing. All right. So I'll stop here for a while. I'll also ask you to do that for now. Okay. All right, so guys, let's continue. Hopefully you were able to do it yourself also. So this is what I have for you. So this time I'm doing this. I am subtracting something from x, okay? So again, I'm choosing different values, 0, positives, negatives. So I started out with, I am subtracting a positive number. So take a look. This asks me to put in a p, which is positive, so it's x minus p, all right? So when I put in a positive number, I'm subtracting a positive number. What do you notice? Okay, so this is the graph, all right? And then, if you compare it to the original, you might have noticed that something happened. And I would like to talk about that once we get to the second graph. So for now, just take a look again at what happened when we subtracted 1, all right? This is the graph for it. Okay. Next. I did x minus 0. So I just put in a 0. Well, obviously, this one is just y equals x squared, all right? And this is the original graph. Now, again, that's the parent graph. Now, you might want to compare this original graph compared to when 1 was subtracted from x. Look at the vertex. Where did it go? The original is y equals x squared. When 1 was subtracted from x, this is where the vertex is now, all right? So I want you to think about that as we go to the next one here. Now, when we're doing x plus 3 squared and comparing it to what it asked us to do, which is to subtract, what actually happened here is I subtracted a -3. All right. That's what I did. However, of course, when we subtract -3, it becomes addition. Okay. And take a look at the new vertex. All right. So in the original, It's this one. Okay. When I sort of subtracted -3, the vertex moved. Okay. So I hope you see something happening here. All right. So in summary, when compared to the original, which is y equals x squared, when something is subtracted from x inside the square, all right? So it's inside the bracket and something is subtracted if it's positive. If you subtract a positive number, it moves to the right. The graph moves to the right. As you can see, the vertex moved to the right. When something is subtracted and it is negative, so you subtract a negative number, it is inside the square, it goes to the left, all right? So really, the sign of the number that you are putting in there tells you where to go. 1 is positive, it went to the right. 3 is negative, it went to the left. You got it? Okay, next. So there's lots of graphs here, all right? This time, it wants you to come up with what is the graph of y equals ax squared, provided that there are certain values for a, okay? So once again, the original is this one, okay? So the vertex is at 0, 0. Okay. Now, I thought about, okay, if I put in a number which is positive greater than 1 in front of the x squared, I wonder how it would look like. So I put in a 2 here, right? So in this case, I put in a 2x squared. All right, now guys, compare it to the graph of this. Okay, so they both have the same vertex, but I don't know if you noticed, but 2x squared, the graph of 2x squared, seems to be a little bit skinnier. All right. Now, if you're like, oh, I'm not sure I see that. Okay, let's come up with another one. 10x squared. I made the number in front of the x squared a lot bigger. Now, here you can obviously see that the graph is a skinnier version of x squared. All right. Okay, I think that's pretty obvious. Okay. Now, what if I put in a number that is less than 1 but greater than 0? So it's like a decimal or a fraction. So I'd like you to compare this. All right. So again, y equals x squared is the original. It's this one. I put in 1 equals 1/2 x squared. All right. So this one is the new graph. It is actually a wider version. In fact, if you compare it to this one, y equals 2x squared, and its reciprocal, y equals 1/2 x squared. 1/2 x squared is a wider version of 2x squared. Okay. What about 1 over 10x squared? So I know that y equals 10x squared is going to be a skinnier version of y equals x squared. Y equals 1 over 10x squared is a wider version of y equals x squared. Okay. What if I put in a negative? So now guys, take a look. Y equals x squared is this one, the original. When I put in a -1, what do you notice? Oh, this is the new graph. Compare it to the original. It just flipped over, right? Same width, same everything, except that it just flipped over. Now, what if I put in a value? So this one is -1 over 10x squared. Compare it to the 1 over 10x squared. What do you notice? Again, they're the same. It's just a flipped version, all right? So what does it show us? Well, when we have a negative in front of the x squared, that means it is an upside down version. It is going to be opening down. If there is a number in front of the x squared, which is positive and it's greater than 1, it is a skinnier version of y equals x squared. All right. The bigger the number in front of the x squared, which is positive, the skinnier it's going to be. If the number in front of the x squared is going to be a fraction or a decimal between 0 to 1, it is a wider version of y equals x squared, like this one, or this one. All right. Now, if it's a combination of a negative and a fraction, all you need to do is think about the wider version of y equals x squared and then flip it over, as you can see here. So y equals negative 1 over 10x squared is just y equals 1 over 10x squared, which is a wider version of y equals x squared, and then it's flipped over. Okay. And I think that's it for me. I hope that helps you out. Okay. Thanks for watching. Do the homework. Bye.